So welcome everybody. My name is Paradis. I'm a software architect at Salesforce. I've been with Salesforce for about 5 years, and I've been focusing on the Lightning platform, which is the software as a service development environment that we have in Salesforce. And over the past year and a half, I've been focusing on the technology called Locker, which allows sandboxing in the browser without using an iframe. So today I'm going to talk about our experience using OCAP at Salesforce and how we were able to move from an early system to pretty much a basic OCAP system. So first of all, these are the things I want to cover. First, we'll talk about what's our challenge, what we're trying to protect, what's our proposal. We'll review a little bit what the homebrew system was, how we came about starting to secure that platform, and then talk about the adoption of OCAP and other standards and what were the results of doing that migration. So it's pretty much of a different talk we're going to have. We're going to see a bit more about hands-on application of OCAP and how we're able to solve the different challenges there. So first of all, Salesforce, for those who don't know much about this obscure company, like very often I get here, what is Salesforce? Basically, it's a large database in the cloud. It's an Oracle database with a rich GUI. It serves basically needs of businesses, CRM, financial, communities, marketing, sales, analytics, and even Einstein, which is the machine learning systems. It started as in 1998. The idea was no software at the time, meaning that for business you don't have to install servers, you don't have to deal with backup. It was quite new at the time, and it grew up from there to a business of about $8 billion per year in revenue. It has great mobile integration. It has an amazing level of customization, both programmatic and declarative, which for some businesses is very interesting because the fact that it is declarative, you don't have to hire developers in order to customize the system to your needs. 3 languages, Apex, which is a subset of Java, goes on the server. Visualforce, which is the traditional one page, not the single page, but the multiple page framework, and now the Lightning platform, which is the system for multi-page, single page web app. It has an app store and it has an app builder, which we're going to talk a little bit more about. So this is what the UI looks like. So if you've seen Wix and all of these great UI builder, this is it should be obvious to you. On the left side, you have a series of components. They provide different rich UI experience, rich functionality. You can drag them on the page and customize the page, and as you select them, on the right side, you can select different properties to those components. And everything is made to be fully adaptable. If it works on the browser, on the desktop, it will work on mobile. So it's you basically have your business on the go with you at any time, which is one of the reasons why so many businesses love this. Now, this is the App Store, view of the App Store, where you can buy some of those modules. You don't have to build them. You can buy them from different vendors. We call them ISV, or industry solution vendors. And they do all kinds of things. Some have access, you give them access to your data. You can process the data, some can process email. All kinds of systems are available. You can use them to compose your page, or you can build your own component using some of those as resources. So it's a little bit like years ago we used to have a Flash environment and you could buy Flash modules. So basically a reinvention of this component-based architecture. So AppExchange ended in 2006, 5 million registered developers. We have they're used by over 150,000 orgs. It's translated over 100 countries, and of those different packages that you see, there are over 6 million installed solutions distributed. So lots of code sharing between those organizations. The challenge was to secure all of that, especially when we moved to a single-page web application, because suddenly a component on a page would exist for a certain amount of time and could be looking and monitoring activities on the page. So we developed Locker, which is a virtual iframe. I'll get into more details, but these are the early proposal for Locker. It was to basically make sure that each module acts as a separate tenant on the browser, so there's no communication or stealing of data between them. It's also a way to prevent those modules to access our API or access unsafe or what we deem unsafe browser APIs. It's obviously one of the biggest threats is XSS, so all of the methods like inner HTML are tamed and they go through a sanitizer. And so there's no, even if CSV is not enabled in the browser, there's no possibility to go through and inject malicious code. And we basically sandbox the DOM of every one of those widgets, so one cannot see the DOM elements of the other. Now, why we're not using IFrame? Well, first of all, let's take a look at the typical use case. So our components originally are based with a Java backend, so there's a heavy XML flavor around it. So we have the concept of a namespace. So we have these different widgets here. So NS1 weather, NS1 map, NS2 finance. Those are the different widgets that we drag on the page. And NS1 is the order or the namespace. What we do is each namespace is basically a realm or like a virtual iframe. And what the goal here is to isolate those things. So for example, NS1 weather is using a potentially malicious library, a map library in its subcomponent NS1 map. And then the map could have access to the financial data on the page and then use that to get early indication of how a business is doing. So our goal is to prevent dump scraping from one or the other. There are other things, but this is the basic, probably one of the most obvious use cases. So we have two square, NS2 and NS1. Why not use an iframe? So we want to preserve most of the security properties of the iframe or the isolation that the iframe provides. So different globals, different set of DOM elements, cookies. The cookie jar is sandboxed. The local storage, session storage, and a few other, all of the global API that are on the page level are brought down to the sandbox level. But there are a few things we didn't want from the iframe, which is the iframe. You have to reboot your framework in every iframe. We wanted to avoid that. We wanted to boot once. And if you start to build a rich UI, you don't have to. You can reuse a shared framework. Wanted to also avoid content clipping. So you have a drop-down menu, or you have a dialog box, or you have clone tooltips. An iframe will provide hot clipping. And especially when we want to have nesting, it's becoming very difficult with iframes. So Locker is what allows us to get around that issue. So simple view of Locker. There are many ways to look at it, but basically we have an initialization where we repair and freeze the browser. Then we are in a good position to evaluate some source code. Yes?
Quick question, is your DOM isolation by like DOM subtree, or is it by region on the page?
What we do is we tag DOM elements.
Tag that.
So every DOM element receives a key, and every method that the user, every tamed method that the user has access is going to receive only the DOM elements that are keyed for that namespace. So every time you create a DOM element in your namespace, you get a key attached to what you've created. You never have access to the raw object, and nobody else will be able to receive your DOM elements because they keep with your own key. And there's only a one-to-one relationship between a namespace or realm and DOM element.
So you're not worried about one namespace overlapping another namespace?
We do, and there are some CSS properties to prevent that. So going from source code, we have our confined evaluator, and that is presented to an execution context inside of a secure global and very secure object. And that execution context has access to the pure or the basic JavaScript API, and through aimed object has access to the GOM API. Now, when we did all of this, and these guys started working on this way before me. We had a lot of bright people working on this. But it happened that we reinvented a few things that existed out there. We decided, or somebody at one point decided to sandbox no-vetted code. So instead of going line by line and say, we'll only allow on the platform the code that we fully look line by line, we say, we're going to sandbox it. So the code can run in a user namespace, but has no access to the Salesforce API. Well, that's what other people have been doing. If you look at how many times you have to accept license agreement every time you change a piece of software, and how much taxing it is, imagine doing that for every line of code every time you have a change in the library. It's an impossible task, and this allows the platform to exist. Same thing, the split between JavaScript and browser API. We happen to look we have two different parts of the code, and it happened by just looking at what makes sense to the early developers of Docker. And this is what Google is doing with Tomato and SCS. Language-based security, tons of papers have been written about it, using JavaScript to secure JavaScript. And finally, the membranes. We have a membrane in Docker, and we didn't even know there was a membrane. It's just the folks decided to have a caching system. So every time you create a saved version of an object, you save it in a cache, but you also save the reverse, so you can unfilter that if you present it at one point with a filtered object. And those two things were in two different places of the code. And looking at Kaha and a double weak map of Kaha SCS, which not tame to furl and furl to tame, we just refactor the code and they didn't say side by side. So all of this is by accident made Locker a very good place to move to OCAP. We were very, very fortunate. So gradually over the past...
Did I just
yes.
Since you said by accident, I just want to interject.
Yes.
It's kind of accident that I had worked to purposely to set up for people to have these accidents by working on the standards committee to shape JavaScript into a language in which there were the enablers for doing object capabilities. What I did not imagine, which I'm very gratified with the Salesforce work, is that without ever knowing about object capability, without ever knowing that the enablers were there for that purpose, Salesforce simply encountering the problem and the need and seeing the enablers reinvented the whole thing from scratch before they looked at our work. That's pretty great.
Yeah. As soon as we discovered that others had been there, we went full on into the direction of using standards and also collaborating to standards. One of the key things for us for the platform is, and Docker will be open source at one point. We're in the process of doing that. But one of the key things is much more than transparency. We want to avoid also people to be locked with the platform. We want to avoid them. If you're a PhD in JavaScript, you don't have to relearn everything to do JavaScript the Salesforce way, so following standards is important. But more than that, contributing to standard for us is a way to prevent our customers or guard them from having to rewrite their code in the future, because maybe realm will happen or ports will work a certain way, and what we want to present them today has to have a foresight into the future. So we're doubling down on the standard and the collaboration with the standard. So just basically, if you've never seen a membrane, these are the key things of a membrane. You have some kind of handler that introduces some kind of distortion. Two-weak map that allows you to do the conversion between the system. Your safe object is a proxy over an unsafe object. And after you've created it, then you record the two map, and that was all in the code, and that's something you could see in many systems. So this is the attenuator, and we have our system works with a metadata-driven attenuator where we more than whitelist, we identify clearly what are the APIs that we allow, and we have a system to declare for each method what is the appropriate behavior. Is it a generic type of handler, or is it sometimes in some cases where the more targeted handler, for example, for HTML, which goes through a third-party library called Purify. So working with Mark, or working with Agoric, we have this proposal at TC39 for the realm, and we have a ship, which is an implementation of this realm. We went this summer through a heavy exercise of vetting the code, simplifying it. We have under 700 lines of code for the kernel. Every line of code has been vetted and talked over and over. 500 tests, 90% code coverage. It's at that address if you're interested. And it's being reviewed by us, our internal red team, Agoric, and also third-party security reviewers. And since we had it, and we use it in production, we've been able to close some issues that nobody knew how to resolve. And it's been challenged many times, and it's remained standing for all that time. So we're pretty happy with that collaboration. So just nothing very technical, but just this idea about the membrane and the realm, how one is the opposite of the other. The proxy or the membrane, where you wrap and you attenuate the object, it's a proxy over an object, whereas the evaluator or the realm is basically a width over a proxy, so it's a reverse proxy in a certain way. The goal of the membrane is to prevent you from accessing unsafe method of an object. The goal of the realm is to prevent you from escaping that evaluation. When you put them together, you get this kind of system where the sandbox code runs inside of a realm, and all of the object it's presented with are tame, and it doesn't have access to the global context where we have code running in pure system mode and not affected by any degradation of performance that the membrane can do. So now, okay, we have this system and we need to roll it out. So we have this triple challenge where we have product security jumping and says, fix it, make it secure, and our end user always want faster, and all of these extra methods, they have overhead. And our developers say, well, the whole DOM API has to be exposed. Initially, we thought we would do only the surface area for the Lightning platform or the web components, but then people want jQuery, leaflet, and whatever, D3, and then we have the whole DOM API to support. So how do we challenge those things? How do we start about this? So the way we went is to realize that the most important thing is adoption. If we have a secure system and people refuse to use it, we don't have it. So performance is the sum of, adoption is the sum of performance and compatibility, so we work really hard on those aspects. And at the end, the countermeasure, we do obviously threat modeling, and we bring the countermeasure, but the countermeasure plus adoption gives us security. So internally, we've been able to make leeway by focusing on the three things at the same time. Like, it sounds alien to say maybe we should put all the innovation security, but it's not. We're not doing any detriment to security to put a lot of innovation performance and compatibility. So for performance, we have a deep freeze operator now. It's taking 5 milliseconds to freeze the whole JavaScript, and an extra 2 milliseconds if you add international. The eval itself, we provide a safe eval to customers. It's 1-to-1 or 2-to-1 depending of the type of code. Access to global constant like object is like 1-to-1. There's no degradation, even if we have a width over a proxy, because we have methods to optimize that or re-optimize what is de-optimized by the JIT. And obviously define and retrieve constant on the global. There's a little bit of a performance gain. So we provide our developers tools that they can measure performance. They can evolve their code. We have a playground basically where they can measure the performance of their code and optimize it. The attenuation, the different calls, well, it depends on the attenuation. Like HTML will be much lower, but overall, what we're able to get, and our target is a 5% overall for most applications. We get locker on, locker off. We get a 5% difference. There are exceptions, but that's a generic case. So adoption is tremendous with those numbers. Compatibility, well, we use a lot of the standard tests. We treat Locker as a virtual browser, and we bring those tests inside jQuery test suite, test 262. We've just added the web platform tests. And we also run Jet3. Some of the benchmark I've published in the past were based on Jet3. Yeah, and the idea is to align on standard to reduce the what I mentioned before, the barrier of entry to this system. So security, a few things we do. Obviously, everything has to run in strict mode. It's a limitation of the evaluator, but it has a lot of other benefits. We have this whitelisting mechanism that I'm mentioning. So if anything happens and then is new in the browser, we don't allow it until we have a time to review it, and we have tools that calculate the diff between what is in the browser and what we support. We use a system where we call it stricter CSP. It's not strict CSP, it's stricter CSP, where we still allow and CSP will unsafe eval, so we can use it in our code internally to receive libraries from the Salesforce system. But we remove unsafe in line because it's usually where the XSS happens, and it's probably the most useful of the two, because the unsafe eval can be easily emulated by fixing two functions, and what we know of is the star function star constructor. So then there's no way to get the violation in the browser. So as I mentioned, we closed all open issues that we had at the time when we brought this technology in, and it's still the HackerOne and all these guys are still trying to get through, but so far it's been quite successful.
Is there a prize posted at HackerOne?
Yeah. Yeah, we just had one exercise it was the first time Locker was on HackerOne. A lot of our system at Salesforce are, but that was in August, and it's stood still. So that was pretty happy. So nothing much more technical than this. It's just an experience of moving to an OCAP-based system where we have attenuation, we have membrane, we have different different actors on the page, and they're securely put together through those OCAP principles. Thank you.
So that was great. I'm very curious, since it sounds like your team and rollout are kind of new to being immersed in the OCAP space. And Kate and I were just talking about trying to make OCAP stuff clear to more people, and sometimes there's a general cursive knowledge problem when you've been immersed for a lot of things a long time, where it's hard to tell what things are clear and what aren't. So I'm very interested in your perspective of what was it like being immersed in OCAP land? What can we do to make this stuff more understandable? What went well in understanding it? What was hard?
I still think that there's no clear definition of OCAP for a lot of people. It's very the base language in which OCAP is discussed is quite. There's a high step to get there. So the barrier of entry is high. A lot of paper exists on the subject. There's a great article by
Chip Windsor?
Yeah, Chip has done what's the name of his paper? I think that's the clearer one that I've seen, and it's still difficult. Basic concept like confused DPT and all those things, if they can be isolated, could be very useful. But it's very abstract, and I think initially you would get lost, or you would naturally run toward more classic systems like ECL in order to resolve those issues. The fact that Locker has no ECL is just mind-blowing for a lot of people. So, yeah, I think it's a dream one day somebody will write a book about this. That could be useful. I think also another thing to add to this, OCAP seems to be a little bit like Agile. It's not necessarily a solution as much as a journey of thinking about what you're trying to expose, and that can lose also people looking for simple solutions.
Chip's essay, Chip Morningstar's essay is called "What Are Capabilities?" And you can find a link to it in the references section of the agoric.com website. So what you explained as what you're achieving with OCAP in terms of encoding users seems like it's all in terms of isolation. And OCAP is, any security model has to start with isolation, but then there's the issue of enabling secure interaction.
Yes.
What kind, since you're together in one page in one realm, you're not going through post message and other things, you have the opportunity for object-object interaction. What use have you made of that?
There's two aspects of it. It's not, we always have Bob and Alice, and then there's always God on the page. So there's always a system. So we already are in interaction between the Bob, Alice, and the system. We currently limit heavily what can be done user to user. With the place where we allow it is because it's a component-based architecture. Every component has a defined interface, and through that, this interface is basically like a post message in the majority of cases, because we're talking about DOM element properties or web component properties. So the type of information that can flow is at that level. It's a string, it's a primitive. We also allows the JSON type object, not going through JSON serialization, but basically primitive plus arrays and plain object. We also allow that to carry across. And object can expose methods, and those methods will also accept those created objects. Using a more traditional way of loading modules, a given organization, so it cannot be done through the App Store, it cannot be done magically through the App Store. Every business can add on their resources, we call that static resources. They can add a folder that contains a lot of resources, CSS, style sheets, jQuery, and there's a method to load that in the page in their sandbox. So they can fully import the library. It's evaluated in their namespace, and only then, only that namespace has access to it. So that's the other way we curtail our collaboration, but we'd love to do it for the App Store.
Okay.
Yeah, you had said that the Locker service has kind of stood up to a lot of criticism and different attacks and things like that. And I was just wondering, where do people guess that it's from? Or if you're just talking to a developer about it, what are their doubts and how do you deal with those? Are there any things that tend to come up a lot?
Yes, of course. I think there's when we deal with a large organization, when we deal with a large partner, we're going to get people all over the spectrum, believers, deniers. A lot of people are very attached to the classic Singularity Policy. I think it's Netscape 2 1995, and they say it's still valid today, and you have to let your code. We still have that today. We still have people, and we have, until we had those, I think there was a critical point for Locker where it could have gone away, and we could have gone back to IFrame to build, but we were able to succeed through that. Now, we just had a Dreamforce. Dreamforce is our annual conference. We do talk Salesforce, but we also have customers and industry solution vendors doing talks. And one of the fellow who works on the platform said, had a very good conference saying, the subject was how I stopped worrying and fall in love with Locker service. And his point of view was that because of Locker, he gets a lot of security commoditized. He doesn't have to deal with sanitizing either HTML every time he touches the DOM elements because the system does it for them. So, and a few other things. They can invoke their own API and not have their data stored by other potential code on the page. So it's all over the place, yeah. Now it's a constant, I think this is why we want to go through these talks and contribute to TC39 because there's value for us in telling the good story when it's running through many channels. That's it.
Okay.
Thank you.